Today I'd like to demo my homemade do-it-yourself reverse delay pedal. It's based on, I used 4 piggyback PT 2399 analog delays. April Fools! Welcome back to Fuzz Lab for Hacking with PD2. Today's April Fool's Day. So yeah, my wife and I had went to the resale store. My youngest daughter is infatuated with the Beatles, so we picked this up. I don't know if you can, how well you can see that, but reloaded. It's not the Beatles. But anyway, yeah, we said, hey, look what we got here, you know. So, April Fools, everybody. Actually, today I wanted to show you this. It's a signal generator. It's like a little piece of test equipment that I threw together. It's a real simple, fun, cheap project. This is also known as the Quick and Dirty Audio Test Oscillator by R.G. Keene, who is like a staple or founding father in this community of do-it-yourself guitar stuff. So much respect and hats off to Mr. Keene. Online, he has a fantastic presence, and he's really contributed quite a bit to the community, so thanks for all your work. Anyway, the reasons why I wanted to build this quick and dirty audio test oscillator, I call it my signal generator. It's a little bit, rolls off the tongue better that way. But basically, you could think of this device as an automatic guitar player. You use it when you're troubleshooting a problem, or also in the design stage if you're changing out all sorts of components. You know, you put the circuit together, it works, but you want to fine-tune it by changing a couple of parts values. A little bit different value on each one will give you different, more treble or more bass. So for the design process, I mean, normally when I'm doing that, what I would do is I'd have a guitar in here, and I would strum it and then turn back around and monkey with it, strum it, turn back around, or sometimes I would call my wife or somebody, one of my kids, to come in here and kind of strum, you know, and after about a half hour of them hitting the same chord, I know the neighbors can hear it. So, and yeah, it gets on my nerves too. So it's just a fantastic device to build. If you're getting into this stuff and you're going to be building a lot of pedals, I seriously recommend you take a look at this schematic and get the parts, because it's just fantastic for a time-saving device. You know, another use for this, you could, it produces a relatively pure sine wave. So in theory, you could hook this up through your pedal to an oscilloscope, or download a program if you don't have an oscilloscope. And what that would enable you to do is see the waveform. You can actually see the audio wave, and because this is a sine wave, which is a nice looking wave, you could tell it's similar to what the guitar wave actually naturally looks like. You can tell with a fuzz pedal or distortion, you could see exactly how the waveform is clipping or distorting. So you'd also have a visual reference point to work from. And if you put a chorus pedal on it, it looks really neat. You can see the voicing moving around in there as you turn the rate up and down. When you go to the schematic and the layouts for this, what it says is the circuit is a basic twin T oscillator. I believe the twin T is something having to do with there's 2 transistors in the circuit and they have 3 legs. So when you look at it, there's, I don't know, I would call it a twin Y because they look more like Ys, but twin T oscillator provides a relatively pure sine wave at approximately 1 kHz. There's 3 different output levels on the circuit, 1, 10, and 100 millivolts, the 100 being the closest volume of a newly struck guitar string. So this is, you know, like I said, it's for audio and effects testing. You could use this device to troubleshoot broken down audio equipment. It's not just for guitar pedals. The circuit it's a real basic circuit. The parts, there's not that many parts. It uses a 2N3904 transistor. Radio Shack part number 276 2016. They're a $1.19. That's a 2N3904. There's 7 resistors, 6 capacitors. There's a 0.022, 0.01, and a 1. And those are non-polarized, like a little Mylar orangey buddies. You could use those. Optionally, you know, on mine, I added an LED. I have a volume pot. I put in a switch to toggle between those. There was the different volume levels, the 1 millivolt, 10, and 100. So I threw a toggle switch in there, and I didn't use the 1. I used the 10 and the 100. And then I've got the volume knob to kind of fine-tune so I'm not blowing my doors off or too quiet. This circuit, it could run just fine off of a 9-volt battery, or in my case, I didn't even bother with that. I have a power supply here, so I went ahead and threw a DC input jack on it. I constructed it with strip board or Vero board, which I ordered, but you could also use a perf board for this project too. So basically, you get the idea. It's a noisemaker. It produces a sine wave. It's not a perfect sine wave. So if you were doing real intensive testing or something where it was really high fidelity, you know, this thing, it's called the quick and dirty test oscillator. Quick because it's a simple circuit. Dirty because it's probably distorts a little bit and the sine wave isn't pure. So don't calibrate your atomic microscope using this wave that this thing puts out. So I'm thinking at this point, I rambled on long enough. I'm going to go ahead and part 2 of this video, I'm going to demonstrate the unit, and I also have constructed a do-it-yourself audio probe, which is a little guy that you're going to use. You can hook that up, and it aids in troubleshooting. So in part 2, I'll go over that, and then I'm going to demo everything. So April Fools, keep on hacking.